series of lectures of gamma distribution. Today, let me see what is mode of gamma distribution. So we know that mode is nothing but the maximum. So we need to find the maxima of fx, and the maxima of fx is found by using the formula f dash of x is equal to 0, which gives me some value of x is equal to a, and f double dash of x is less than 0 after having the value of x as a. Okay, now since x follows gamma with parameter theta comma n, therefore PDF of x is fx is equal to theta raised to n, gamma n, e raised to power minus theta x raised to power n minus 1, x greater than 0, theta comma n greater than 0 is equal to 0 otherwise. So to simplify the term, we can have fx is equal to f and taking log of both sides. So what we get? See, we get this as log f is equal to, since this is constant term that is free from x, so we can have the log as it is, that is theta raised to n upon gamma n, because derivative of this term gives me answer at 0. Now the log of this is minus theta x, plus we have n minus 1 log x, plus n minus 1 log x. Okay, now differentiate this with respect to x. What we get? We get f dash divided by f is equal to 0 minus derivative of this is theta plus n minus 1 upon x. Okay, so that means f dash is equal to minus theta plus n minus 1 upon x into f. Let me have this as equation 1. But if you observe the condition f dash of x is equal to 0, that means this f dash is equal to 0. So if I put f dash is equal to 0, what we get? See, so minus theta plus n minus 1 upon x into f is equal to 0. So that means what I have? N minus 1 upon x is equal to theta. That means x is equal to n minus 1 upon theta. N minus 1 upon theta. That is the value of x is n minus 1 upon theta, which is mode of gamma distribution if it satisfies the second condition. And the second condition is f double dash of x less than 0. So let me have the condition. So since this is my f dash and f dash, this is my equation 1. So let me differentiate this again. What we get? See, f double dash is equal to first bracket as it is. So minus theta plus n minus 1 upon x f dash plus. Now the derivative of bracketed term, minus theta derivative of this is 0 and the derivative of this is minus n minus 1 upon x square into f. Now if you observe this bracket, we can put the value of f dash. So the value of f dash is, if you observe both the brackets, they are same, and we can have the value of this as minus theta plus n minus 1 upon x square into f minus. Minus I have this term as it is. So n minus 1 upon x square into f. Now put the value of x as n minus 1 divided by theta. What we get? We get minus theta plus n minus 1 divided by n minus 1 upon theta x square f minus n minus 1 divided by n minus 1 upon theta bracket square into f. So let me simplify the term. N minus 1 get cancelled, and I have the term as minus theta plus theta square into f minus 1 of n minus 1 get cancelled. We have theta square n minus 1 into f. So since first bracket gives me 0, and the answer is minus theta square divided by n minus 1 into f. So if you observe the terms, f is strictly greater than 0, theta is greater than 0, n is also greater than 0, and hence this value gives me less than 0 if. See, since if n is greater than 0, if it is 1, then it gives me, if n is 1, it gives me 1 minus 1, that is 0. Okay. And if it is, if I have put the value of n greater than 0, then this gives me negative sign, and hence f double dash is less than 0 for the value of x. And the value of x over here is n minus 1 upon theta, and hence the mode of gamma distribution is n minus 1 upon theta. Okay. Now let me have the additive property of gamma distribution. So additive property of gamma distribution gives me statement as x1, x2, so on up to xn be n independently distributed gamma with a parameter theta comma n1 comma theta comma n2, so on up to theta comma nn. Okay, so that means x1 follows theta comma n1, x2 follows theta comma n2. Then the distribution of x1 plus x2 plus so on up to xn, this follows again gamma with theta comma summation of I varying from 1 to n. That is the statement of additive property. So that means over here we have given x follows gamma theta comma n1, x1 follows. Okay, so we know the MGF of gamma distribution. So let me write this for I. Okay, so xi follows gamma theta comma ni. Then MGF of gamma distribution is, MGF of xi is, so mxit, this is equal to 1 minus t by theta raised to minus ni. So MGF of xi is, mxit is equal to 1 minus t by theta raised to minus ni. This we know already. Okay, over here I takes value 1 to up to n, obvious. Now we need to find MGF of this term. So let me consider this as y. So y is equal to x1 plus x2 so on up to plus xn. Therefore MGF of y is, let me write over here. So myt is equal to what I have? I have expectation of e raised to power yt, which is equal to expectation of e raised to power x1 plus x2 so on up to plus xn t. So this is equal to expectation of e raised to x1 t plus x2 t plus so on up to plus xn t. So this is equal to expectation of e raised to. See, since x1, x2, xn are independently distributed, we can write this as x1 t into expectation of e raised to power x2 t so on up to expectation of e raised to power xn t. So, but if you observe the definition, this definition and this term, so this is again the MGF of x1. Okay, so that means I can write this as mx1t, mx2t, so on up to mxn t. But I know the value of mx1 and the value of xi is 1 minus t by theta raised to minus ni. So let me have, so myt, this is equal to, now let me put the value of mx1t, and the value of mx1t is 1 minus t by theta raised to minus n1. Again mx2t is 1 minus t by theta raised to minus n2. Okay, 1 minus t by theta raised to minus n2. And so on up to the last value is 1 minus t by theta raised to minus nn. Okay, so this is equal to, now if you observe, this term is common to all the terms, and we can have minus common out of raised to power. So what I have minus n1 plus n2 plus so on up to nn. So this is equal to 1 minus t by theta raised to minus the summation of ni. So if you observe these two MGF, this MGF and this MGF, this term is same 1 minus t by theta. Only the difference is instead of ni, I have summation of ni. So that means by using the uniqueness property of MGF, we say that y follows gamma distribution with parameter theta comma summation of ni. And y is nothing but x1 plus x2 plus so on up to plus xn follows gamma distribution with parameter theta comma summation of ni. That means addition of gamma distribution is gamma distribution only. Okay, so that is the additive property of gamma distribution. Now let me have one more proof of distribution of, let me have distribution of xi, IID exponential random variable. So let I have x1, x2 so on up to xn be IID exponential. IID means independent and identically distributed. That means parameter is the same. Exponential variate. Okay. And we need to find the distribution of x1 plus x2 plus so on up to xn. Fine. So over here we have given x1 follows exponential with parameter theta. Therefore MGF of this x1 is mx1t is equal to 1 minus t by theta raised to minus 1. Similarly, since x2 follows exponential with same parameter theta, MGF is mx2t, and that is 1 minus t by theta raised to minus 1, and so on. Since xn follows exponential with parameter theta, the MGF of xn is mxnt, and this is 1 minus t by theta raised to minus 1. Okay. Now we need to find the MGF of this term. So let me consider y is equal to x1 plus x2 so on up to plus xn. So MYT, this is equal to, MYT is nothing but what we have? We have expectation of e raised to power yt. Let me have the value of y as e raised to power x1 plus x2 so on up to plus xn t. So this is equal to expectation of e raised to x1t plus x2t plus so on up to plus xn t. So this is equal to expectation of e raised to x1t into expectation of e raised to x2t so on up to expectation of e raised to xn t. Fine. So MYT is equal to, if you observe the terms, this is nothing but mx1t into mx2t so on up to mxnt. But all the values of mxit are same, and it is 1 minus t by theta raised to minus n. So 1 minus t by theta raised to minus 1, 1 minus t by theta raised to minus 1, so on up to 1 minus t by theta raised to minus 1. So since this portion is same, I have addition of raised to power, and since the terms are n, we have addition of this as minus 1 so on up to minus 1. It is minus n. Okay, fine. Now since we know that if x follows gamma distribution, x follows gamma with parameter theta comma n, therefore MGF of x is mxt, and mxt is equal to, I have 1 minus t by theta raised to minus n. If you observe both the MGF, by uniqueness property of MGF, we can write y follows gamma distribution with parameter theta comma n, and y is equal to x1 plus x2 plus so on up to xn. Okay, so that means over here x1 plus x2 plus so on up to plus xn follows gamma distribution with parameter theta comma n. So if xi follows exponential with a parameter theta and these are independently distributed, then addition of this nxi follows gamma distribution with parameter theta comma n. Fine. So in today's lecture we have seen what is mode of gamma distribution, then additive property of gamma distribution, and we have, if we have addition of n exponential n IID exponential random variables, then this addition follows gamma distribution with parameter theta comma n.
Thank you for watching my video. If you like the video, press the like button and subscribe my channel.